Okay, this is the historic moment after months of work to get everything working to the point where I could put it into the project box and have everything working, the software and the hardware. So I got the rotary encoder working so I can adjust the time it comes on, the number of hours, and it's reading out the PWM speed, which varies according to the temperature of the probe that'll be inside the chamber, and showing, of course, temperature and humidity inside and outside the chamber, and the time. And then can also turn off the OLED display using the microcontroller and with the display signal. And then I've got a interrupt for controlling the light relay, so I can turn that on or off anytime. And regardless of what the time setting is, this overrides that in the software. 12 volts power. This light shows 12 volt power, and this is the mains power. And then the relay, which is right in here, you can see it going off and on. That controls this outlet, so that's where the lights will be hooked up. And then, of course, the fan is hooked up. The display will be, everything will be mounted in front, of course, but the fan is, can have two fans on here, but one, right now I just have one. Fan is hooked up here. It's being controlled via PWM for speed, and then I can hook up a second fan down there. And then the temperature and humidity connectors are here. I've got a temperature probe connector here in case I want to hook up one of those waterproof temperature probes, maybe for stick it in the soil, something like that, have that readout on here. It's expandable. And then I could potentially have another temperature and humidity readout here. I've got I2C hookup here. It's got a real-time clock module, which is in here, that's hooked to the I2C bus on the Arduino. And what else? So yeah, it's all self-contained. It's got its own 110 volt, mains power that converts to 12 volt, and then it's got a little 3 volt, well, a buck converter that's adjustable, but I had an output about 3.3 whatever volts around there for the display, because it turns out especially having two of these OLED color displays, it draws more power than the Arduino can put out, which is like 100 milliamps on those pins. So it needed its own independent power supply. So this buck converter is hooked into the 12 volts, going from the 12 volt down to 3.3 and then into the display with common ground. So that's pretty much it. And then I did a breakout of the USB from the, see if we can see it in here. Oh, it's not hooked up right now, but anyway, it goes here. This hooks into the board, so then you can externally hook up the USB and then just update the software at any time for whatever functions, whatever ideas you have, and like a firmware update. Pretty cool, huh? But yeah, I got a rotary encoder. I can now, so here I can adjust the, depending on the length of the push. Here's adjusting the number of hours on, put it up to 18 hours. And then you press it again to go out of adjustment mode. You do a long press, and that'll adjust the time it comes on. So there I did it. I just changed it down to 5, back to 6, and then go out of adjustment mode, and you're back to readout. So that's much nicer than using potentiometers, plus it's all in one. Finally got it all working in one rotary encoder instead of having to use 2 of them. I discovered that little function from the rotary encoder library allows you to measure the length of the push, and then you just have to have the right settings for the timing, and it's a little bit quirky because you have to time it just right, and so it's best to use an interrupt, but there weren't enough interrupts so far. The only thing I would like to have is it come on at dawn, but there wasn't enough memory in this Arduino Nano to have that dusk to dawn library, so maybe I'll use a Arduino. I got some of these Nano Everys which have more flash memory, so let me try that out, because that would be kind of cool, fun to be, have it come on right at dawn, and then I'll show you a readout on here when dawn is, and then it's kind of nice to know that. Could actually have it both read out dusk and dawn just for the heck of it. So yeah, I got the AC on over there because it was like almost 80 degrees, 79, and it's coming down now. So the fan map numbers dropping, slowing down the fan. I would like to have an actual RPM readout, but that's a little bit tricky given the loop and the interrupt and stuff, so I'm going to work on that. All right, that's it.